For today, I'm going to go over the answers that you guys worked on just now during class and on page 27 here. So number one said it took 500 newtons of force to push a car 4 meters. How much work was done? So this is just a simple plug and go equation here. So we have my force, 500, my distance, 4, and we just plug that in. So 500 times 4, that equals 2,000. And then work is in joules. Next one says a force of 15 newtons is used to push a box along a forward distance of 3 meters. Find how much work was done. Again, this one should be a simple plug and go. So you have a force of 15, a distance of 3, that's 45 joules of work. All right, now they start getting a little bit trickier. So for number 3, we have a force of 100 newtons was needed to lift a rock. A total of 150 joules of work was done. How far was the rock lifted? So I have my work, I have my force, I need my distance. All right, so when we look at the triangle, work equals F times D. If I want to solve for D, I just visualize and cover up that D and then look at it as in terms of W over F. So I have distance equals W over F. All right. So work is 150. Force was 100. So you have 150 divided by 100. That equals 1.5. And then you got to make sure you get your right units. That is meters because we're doing distance, right? All right, number 4, Max exerted a force of 9,000 newtons on a stalled car but was unable to move it. How much work did he do? So remember that one of our requirements in order for work to be done is that the object must be moving. All right, and so even though I want to know how much work is done, I have a force, I actually don't have a distance. Like my distance is 0 because it was stalled and I ended up not moving it anywhere. So we're going to put 0 in for that, and then when we go ahead and calculate it, you can prove, using W equals F times D, that even though I have a force of 9,000, if I times anything by 0, I get an answer of 0. Number 5 says a 5 kilogram rock is lifted 2 meters. Find the amount of work done. So remember that kilograms is a form of mass, not a form of force. And so I'm going to have to do some calculations here. I have, obviously, my distance is 2. My work is what I need to find. But my force is going to be, I have to do some extra work for this one. So I'm going to have to use M times A in order to find my force. And so that is 5 times 9.8. 9.8 being the force of gravity. Since it's being lifted up. All right, so 5 times 8 equals 49. So 49 newtons is my force. Now I can go ahead and plug this in. $49 times 2. $98. Again, that will be joules. Okay, so again, I had to take my mass, 5 kilograms, times the acceleration due to gravity, which is going to give me the weight of the rock. In the weight is a unit of force, so I can use that for my F, and then just plug that in. All right, number 6 says how much power is used if a force of 35 newtons is used to push a box a distance of 10 meters in 5 seconds. So normally my equation for solving for power, again, is, we just learned this yesterday, power equals work divided by time. So I have my time. Now, as far as my work goes, I don't have my work in terms of like joules. I have a force and I have a distance, and that's enough, because as we learned up here, W equals F times D. All right, so I'm just going to go ahead and plug that in instead. So my force here was 35 newtons times my distance, which was 10 meters. So that's 350 joules of work. So now what I can do is I can go ahead and plug that in. I also could have plugged in and used one of those second equations that I had you guys write down yesterday, which look like this. Power equals, instead of work, we could have just done F times D over T. All right. In either case, that gives me 35 times 10 over time, which was, 5 seconds. So either way, you'll get there. So 350 divided by 5. Okay. It should be 70. Let me just check. 350 divided by 5, 70. Okay. Now just got to remember your units here. Okay. So 350 divided by 70 and gives me 70, or 350, divided by 5 gives me 70, and I'm solving for power. So these units either need to be joules per second or W for watts, or if you wanted to write out the word watts, you could too. All right, number 7 says if 270 watts of power is used in 42 seconds, how much work was done? So in this case, I have my power, 270. I have my time. I just need to solve for work. So I'm just going to rearrange the equation using the triangle method. So I have W equals, and then because P and T are next to each other, they'll be multiplied by each other. So W equals P times T. So my power times my time. So I have 270 times 42. 270 times 42, 11,340. Okay. So again, that one's just rearranging the equation there to solve for work, energy. Number 8, how long does it take to do 278 joules of work with 17 watts of power? So again, I know it's going to be a power one. So I'll plug in my P. I got my W, and I just need my time. So I'm just looking at the triangle here, solving for time. So time is going to equal W divided by P. Oops, sorry. Time equals W divided by P. So that's 278 divided by 17. So I'll go ahead and just round that to one decimal place, 16.4. And we're looking at time, so that is seconds. All right, so time is equal to work divided by power, 278 divided by 17. Number 9, a pulley is used to lift a piano weighing 1,000 newtons. The piano is lifted 3 meters in 60 seconds. How much power is used? So I know this involves a power equation. So I need P, I need W, I need T. I already have T. My W is unknown. But I don't have work in here. I don't have anything that says joules, but I have a force, right here, and I have a distance right here. So that is another word for work, right? Or that's another way that I can solve for work. So remember, I just use that equation up here. So I have P equals, I can do F times D over T. Instead of work, I'm just substituting F times D. All right, so I have 1,000 for my force times 3 for my distance divided by 60 for my seconds. So that's 3,000 divided by 60. That should be 50. And then my final units are power units, which should be joules per second or watts. Like I said, you don't always have to put down both of them, but you know, I kind of change it up depending on which one I want to use. All right, so again, my work had to be F times D. All right, number 10 says if it takes 276 watts of power to move an object 36 meters in 14 seconds, what is the mass of the object? So this one involves, obviously, the power equation. It's going to involve that third one in the power equation where I had to solve for mass, which was, I had this equation here, P equals MAD over T. So I had you guys write that one down yesterday. So basically what I want to do here is solve for M. All right, and in order to do that, I really have to rearrange my equation here. So the first thing that you want to do is get rid of your T in the denominator here. So I'm going to go ahead and multiply this side by T and this side by T. Whoops. Let me give myself some more room here. Okay, so I have P equals MAD over T. And again, this MAD comes from the M and A comes from the force, and the D comes from the distance, and both of those come, you know, together to make work. So again, I want to get rid of my T to get rid of that on the bottom. That'll cancel times T over here. So right now I have T times P equals MAD. And now I still want to get M by itself. So now I have to divide by A, acceleration and distance. That'll get rid of these. And divided by A times D over here. So again, those cancel. And now I'm just going to flip my equation here so it makes more sense for me and rewrite it as M equals T times P over A times D. I'll give you a second to write that down and get that rearranged if you needed to. And as always, if you're the type of person that really likes to put the numbers in there first, that's fine with me. I just caution because sometimes that can, with all the numbers in there, they can get a little bit confusing too. So now I have to just identify my other letters here as far as time goes. All right, time was 14 seconds. My mass is unknown. My acceleration, it's not given to me in the problem, but I can assume that it's 9.8. And my distance is 36 meters. And again, my M is my unknown. All right. Now I'm going to go ahead and plug these in. So I have time 14 times my power, which was 726, divided by 9.8 times 36. Alrighty. Now I'm just going to go ahead and solve them. So I have 14 times 726, 10,164. And then 9.8 times 36. 353. Just going to go ahead and round that to a whole number here. See, as I'm dealing with big numbers, I'm not going to need that. But if you already did this one and you use 352.8, that's fine too. All right, so then we just simply simplify this. 10,164 divided by I get 28.8 if I'm going to round here. 28. Okay, and so that will be your final answer. Just in terms of mass units, we want to make sure that we get the right units in there, so that'll be kg, kilograms. All right, and then that's all I have for you today.